Hello and welcome to all. Myself Amran Kumar Singh, and today I am going to discuss about the chapter Rest and Motion from class 11th. Here, first of all, I am going to discuss about these two terms individually, rest and motion, and thereafter I will discuss some of the terms related to rest and motion. So first of all, what do you understand by term rest? So rest represent if an object remain unchanged in terms of its position with respect to time. If an object remain unchanged its position with time, then we can say that the object is in a rest condition. Suppose that this is coordinate axis represented by x and y, and here the position of an object is represented at time t1 is x1. Then after some time, if the time changes from t1 to t2, but the position of the object at t2 is still x1, then we can say that this object is in rest condition. Okay, so here we can observe that the position of the object in both the cases at time t1 and t2, at time t1 and t2, the position of the object is x1. Then we can say that the object is in a rest condition. Now we have another term, that is motion. What is motion? An object is said to be in motion when the position of the object with time changes. That is, if you see the two positions of the object at time t1 and t2, if you see the diagram, it is represented here that the position of the object at any instant of time t1 is x1, and at second or another instant of time it is represented by x2. So here, if you see the two positions of the same object, it changes from x1 to x2, and it represents that this object is in motion because the position of this particular object is continuously changing with respect to time. Okay, this is known as motion. In this case, we can say that the object changes its position in x direction. Okay, this example represents the object follow one-dimensional motion, because in this case I am representing only the change in the position of the object in x direction. Only x coordinate is changing in this case. That's why we can say that the object is in motion in x direction. According to passage of time or changing in time, the change in position can be represented in different types of motion. Okay, one classification on the basis of the time changing with respect to position is uniform and non-uniform motion. Uniform motion and non-uniform motion. So what is uniform motion and what is non-uniform motion? Uniform motion, as the name suggests, that uniform represent if any object changes its position in such a way that it travels equal distances in equal interval of time, then we can say that the object is in uniform motion. Suppose that here two position of the object is represented at time t1 and t2, which is represented as x1 and x2 respectively. So if t1, suppose that t1 equal to 10 second and x1, t1 equal to 10 second and x1 equal to 20 meter. Similarly, t2 equal to again 10 second, next 10 second, and x2 equal to again 20 meter. From here to here it is 20 meter, and from here to here it is also 20 meter. Time is constant in both the cases, that is 10 second, and it is also 10 second from here, from this point to this point, from 1 to 2. So if you see the diagram, this object covers a distance of 20 meter in 10 seconds. Again, it covers next 20 meter again in same time, that is 10 seconds. Then we can say that this object is in uniform motion, because during its motion it always changes its position with a constant rate, that is it travels or it changes its position equal distances in equal interval of time. If I take another example for uniform motion, here 4 points are represented for motion of an object. These are represented as 1, 2, 3 and 4. Okay, and for each point the time is t1, t2, t3 and t4 respectively. Okay, so here if you see the distance from y-axis to 1 is x1 and it is represented as 10 meter. From 1 to 2 it is also represented as 10 meter. 2 to 3 it is also 10 meter. 3 to 4 again it is 10 meter. And time is t1 equal to 5 second, T2 equal to 5 seconds, T3 equal to 5 seconds, and T4 equal to 5 seconds. Then if you want to find out the velocity, it will be velocity, or you can say that in this case, or magnitude of this, the velocity, that is speed, it is x1 upon t1, means 10 upon 5 equal to 2 meter per second. Again, for point 1 and 2, again it is 10 upon 5, it is 2 meter per second. Similarly, for 2 and 3, again it is 2 meter per second. Then from 3 to 4, it is again 2 meter per second. It is the rate of change of position with respect to time. If you see in all the four cases, the rate of change of position with respect to time, which is represented as speed or velocity, it is constant in all the cases. Okay, I am not going to discuss the difference between speed and velocity. We will discuss it later. It is also included in this chapter. So I am just explaining you the rate of change of position with respect to time. So here you see all the four cases, the rate of change of position with respect to time is constant. That's why we can say that this object is in uniform motion, or we can say that this object will follow uniform motion. Now we have another term, that is non-uniform motion. If you see the non-uniform motion, it represents that if an object changes its position with passage of time in such a way or in such a manner that it travels unequal distances in equal interval of time. It can be possible that non-uniform motion is it travels unequal distances in equal interval of time, or it can be also possible that it follow equal distances in unequal time or unequal interval of time. Both is possible, and in both the cases the motion is said to be a non-uniform motion. And the third one is if any object covers unequal distances in unequal interval of time, that is obviously considered as non-uniform motion. So here I am taking an example in which an object is in motion and the motion of that object is represented by 4 points at different instant of time with different distances or different positions, we can say that precisely. So here these points are represented as 1, 2, 3 and 4. Here x1 is 10 meter, x2 is 15, x3 is 18 and x4 is 5 meter. These actually numerical value I have chosen randomly. Here the T2 means distance travel 10 meter is 2 seconds and time required to travel distance 15 meter is 2 seconds. Or in all the cases the time is same. So if you want to find out rate of change of position with respect to time in all the cases. So if you see for position 1, so rate of change of position with respect to time is 10 upon 2 and it is 2 meter per second. Similarly, for point 2, the rate of change of position with respect to time 15 upon 2, it is 7.5 meter per second. Similarly, for case 3, that is 18 upon 2, it is 9 meter per second. And the fourth one, that is distance is 5 and time is 2. So it is 2.5 meter per second. So we can see that the rate of change of position with respect to time in all the cases are different. Okay? So that's why in this case we can say that the object is in non-uniform motion. Here also the rate of change of position with respect to time represented in terms of v1, v2, v3 and v4. Now, in second case I have written here that an object is said to be in non-uniform motion if it covered equal distances in unequal interval of time. First one I have already discussed. The second one, in which equal distances in unequal interval of time, if the distance in all the cases, suppose that it is 10 meter. The distances are 10 meter in all the cases from 1, 2 and 3 and 4. And time required are different. Suppose that this is 1 second, it is 2, it is 4, it is 5. So again the rate of change of position with respect to time, if you represent the rate of change of position with respect to time, in this case rate of change of position with respect to time in all the cases. Okay, so in first case the rate of change of position with respect to time, that is 10 upon 1 in case 1, that is 10 meter per second. In second case it is 10 upon 2 and it will be 5 meter per second. Similarly, in 3 it is 10 upon 4, it is 2.5 meter per second. And the last one is 10 upon 5, it is 2 meter per second. So here again we can see that the object changes its position when the distances are same for all the cases x1, x2, x3 and x4, and that is equal to 10. But the time required to travel each 10 meter distance is different in different cases. In first case the time is 1 second. In second case, for 10 meter distance it is time required is 2 seconds. In third case it is 4 seconds. In fourth one it is 5 seconds. So here we can see that the object travel equal distances in unequal interval of time. So in this case also the object is said to be in non-uniform motion. In our daily life when we travel from one point to other point, like from our home to school or college or office, by any mode of transportation, like if you moving in barefoot by road, or if you moving on bicycle, or if you moving on any other vehicle, generally the motion is non-uniform motion according to the structure of road as well as the traffic, like that. These factors are affect your motion. So that's why in practical case, generally the motion is of non-uniform type when you moving from one place to another place. So we are here we have seen mainly four terms, that is first one is rest, second one is motion, another one is types of motion, that is uniform and non-uniform motion. Rest is the condition of an object when the position of the object will not change with the passage of time, is called as a rest condition, or object is said to be in rest condition. Suppose that any object present in your house, that is table, bench, desk, or if I am standing here, that's why I am also considered as I am in rest condition, because my hands is in a moving condition, but overall as an object I am in a rest condition, because with respect to time there is no change in position of mind takes place. Second one is motion. So motion is when an object changes its position with respect to time, then it is said that the object is in motion condition. Okay, if you in your house, if you move from your room to kitchen, if you move from your room to main door, or if you move from your room to your school, college, like that, or any other, that is known as motion, because your position is changing, continuously changing with respect to time. That's why it is said that you are in motion condition. Or any object which changes its position with respect to time, then the object is said to be in motion. Okay, and it is of two types according to position and time. So motion is classified as uniform and non-uniform motion, we have also discussed. And uniform motion is the motion of an object in which the object travel equal distances in equal interval of time. Then it is said that the object is in uniform motion. Or we can say that if the rate of change of position with respect to time of an object is constant during their motion, then the object is said to be in uniform motion. And in non-uniform motion, if the object changes its position with respect to time, but it changes its position in such a way that it travels equal distances in unequal interval of time, or unequal distances in equal interval of time, or unequal distances in unequal interval of time. In all the cases, in all three cases, the motion is said to be non-uniform motion. Okay, so in next class I will discuss about the other term related to motion, that is another different types of motion, that is translatory vibratory motion, transitory or rectilinear motion. Oscillatory motion, periodic motion, like that is a different types of motion. Okay, and also I will discuss about term distance and displacement, as well as speed and velocity and acceleration. Okay, so thank you.